Good afternoon. My name is Yan. I'm doing the improving quality and shelf life of fresh cut fruits. Industry partner Perfection Fresh and Woolworths. That's the laser. Fresh cut fruit is a growing market, and in collaboration with Perfection Fresh, we're looking at technologies that can be commercially applied. This is an example of one of the products at the end of shelf life. The current shelf life is 6 days, and the problem is appearance, as you can see from a comparison with a fresh cut watermelon. By cutting the fruit, we're physically damaging the fruit, exposing it to increased amount of oxygen, and this makes the plant to come out with a wound response, and this will increase respiration and also the production of free radicals, which I'll be talking more about interventions. The problems we have with fresh cut watermelons include water soaking, as seen in the first two photos, structural degradation, which causes appearance change, and also softening of the fresh cut watermelons, juice strip, and also when you have juice, you're creating a pool of nutrients for the microbes to grow on. So to improve the quality and shelf life of fresh cut watermelons, I'll be looking at factors across the whole supply chain of watermelons, fresh cut watermelons. And to highlight some of the points here, we would like to know the history of the fruit, the whole fruit, to have high quality raw materials for fresh cut. So to know the cultivars, the maturity of the fruit, and also whether it's been gone through some field heat as well, lower quality than raw material. And in relation back to the wound response, we'll be looking at interventions and factors like controlling the temperature and holding time, minimizing holding time to reduce the wound response. Reducing respiration and energy use of the watermelon itself. Antioxidants would be to work against the free radicals, reducing damage caused by free radicals. I'll be talking a bit more about ethylene in the following few slides later. I'll be screening factors for significance and followed by an optimization to improve the commercial shelf life and quality. In most of the experiments, I'll be dipping whole watermelons into sanitizers before cutting, and then second sanitizing step before storing and before packaging and storing the fresh cut watermelons. So I found juice strip to be one of the potential indicators for shelf life. And from this graph here, watermelon cubes from different locations in the fruit of the watermelon was shown to have different juice strip over time. Firstly, juice strip increased mostly after day 8, and this clearly shows that juice strip can be used as an indicator of shelf life for fresh cut watermelons. And secondly, as mentioned by Michelle, aromatic compounds are one of the first degradation of quality for fresh cut fruits as well. So in this experiment, I put 2 samples, one fresh and one left on the bench for 4 hours, and the fresh ones are in the darker color, And the 4-hour samples lighter colored. So in this graph, you can see after even only after 4 hours, you can see the difference in the aromatic compounds of fresh cut watermelons. So comes in the interventions for the processing stage. Next, I would like to talk more about the ethylene. Ethylene is a gas hormone that's been used beneficially to ripen bananas. But there's also fruits that are very sensitive to ethylene and which accelerate in aging after exposure to ethylene. Watermelon is one of them. We're interested to look at ethylene concentration at parts per billion. In the literature, Wills has shown there might be no lower limit to the degradative effects of ethylene. And for ethylene-sensitive produce, parts per billion ethylene has been related to 10 to 30% shelf life loss for this produce sensitive to ethylene. So these photos are just to show a recent method setup in the lab where air samples are injected into the gas chromatography mass spec, and they are frozen in the loop before going through this system. So we are like concentrating to enable us to measure ethylene down to parts per billion. In another experiment in fruit trays, this is an example of fruit mix at the end. So this graph shows ethylene levels produced by different types of fruits. In this experiment, I packaged them individually and also in a fruit mix with all the fruits shown in this photo for the fruit mix. There's low producers of ethylene, such as watermelon and pineapple, and also there's high producers of ethylene, such as rock melon and apples. And interestingly, honeydew is the highest producer, and the levels are in the ppm region, a few thousand times higher than mentioned before by Wills that can reduce the shelf life of fresh cut ethylene-sensitive produce. Sorry. So in my project, I'll be looking at ethylene levels at different levels of ethylene on fresh cut watermelons. And lastly, ongoing plan of my project, I'll be screening and optimizing the factors over different supply chain stages, and also verifying the improvements at our industry partner, Perfection Fresh. Thank you.